All right, in this video we're going to take a look at scientific notation and specifically how it's being used in our license manuals and our work in electronics in general. And I've put up the SI unit chart up here again because you see right here that we do have some 10 raised to the as a base raised to some number. Okay, and this is to understand this a little bit better, let's take a look at scientific notation. So scientific notation, and I'm just going to call this SN for short, it's a format to write numbers. And the format is very specific. It allows one number, one digit, in front of the decimal point. And then whatever, if it's a decimal number, if it's a bigger number than that, whatever numbers there are. And then times 10 to an exponent. And the exponent depends on what the original number was. Okay, we can put any number into this format. So this is to some power, I'll just write it n. So that's kind of the general rule there. The numbers have to be in this format. So let's take a number like 1,234 and put this number into scientific notation. Now, we've written this as a whole number, but any whole number is a decimal number if we put a decimal point here, and then if it's exactly 1234, then the decimal value would be 0 to indicate that there's no other digits behind there, or it's rounded to this digit. Anyway, what we want to do, and it's easier if you put that decimal point there, then just count back toward the left. 1, 2, 3. To make it into scientific notation, which would be 1.234 times 10 raised to, how many times did I move the decimal point? 1, 2, 3 to the third power. And notice up here that there's a correlation. 10 to the third means 1,000. So this will help you get used to what these prefix names mean if you don't already have those ingrained in your head. Most of us, if we've been around amateur radio for any length of time, and certainly computers, understand megahertz and gigahertz and megabytes of RAM, or whatever we're talking about, millions. Okay, so any number can be written that way. Well, what if I have 1.5 microfarads? Notice it has that mu symbol up here, and that's micro, that's 1/1,000,000th. How would we write that out? We'll start with the decimal point, and micro is 6 places, 6 digits behind the decimal point. So this would be 1, 5, and I need 3 more here. Let's see, is that right now? 1, 2, 3, 4, 5. I did this wrong. I just love it when I do this backwards. That's all right. I don't mind making mistakes. Okay. We know that we have 1, 5, but where does it go? Well, it's got 1, 2, 3. This is tenths, hundredths, thousandths, 10,000ths. So we're getting close. 1, 2, 3, 4. So let's see if I did this right. 1, 2, 3, 4, 5, 6. And the minus indicates that we're going off to the right of the decimal point. So writing this as a decimal number, it has all those places in front. So the number, instead of, when it's greater than 1, it tells us the number of zeros after the significant digit. Here it tells us the number of places behind the decimal point before we get to the significant digit. Because remember, we need one number in front of this. That's why it was written as 1.5 microfarads. They write microfarads rather than writing 1.5 times 10 to the minus sixth. That's what this means. And this is convenient because this is shorthand. In just one symbol, we know what this is. And then, of course, the units that we're in are in farads. All right, hopefully that makes a little bit of sense. So I think the real takeaway here is that when we're on the left-hand side of the decimal point over here, this tells us how many zeros. You can see that. 10 to the 9th, there's 9 zeros there. There's 6 zeros here in mega, 3 zeros here. Each one of these goes up by 1,000. For example, 1,000 million is a billion. 1,000,000 is a million. So, but it doesn't cut back quite, especially in the first two. Then we start adding more zeros in front. But I always think of this as how many places behind the decimal point do I have to go before I place the decimal point. And I get out and I calculate. Okay. Now, the calculator can help you out here. Notice that it has times 10 to the x button. So I could write this value right here directly in scientific notation by doing 1.234 times 10 raised to the third power. They don't raise it in the screen up here. Some calculators will, but that means the same thing. Okay. Anyway. And sometimes your answers on a calculator, if it can't display it, let's take some big numbers here, multiplied by a whole bunch of digits. Notice that the calculator automatically expressed this in scientific notation. This is 1.25 followed, well, it's got the numbers in there, whatever values they are, times 10 to the 14th. There's 14 places we have to move that decimal point to get to the whole number. That's one gigantic number. So anyway, that's another reason why you might want to become familiar with scientific notation, because the calculator will automatically spit that out. If I take a whole number like 89 and divide it by a really tiny number like 0.000025, well, it didn't do it in scientific notation. I needed a tinier number, I guess. But the point is, it would soon want scientific notation. Okay, get used to this system, what they're called, what the power of 10 exponent means, and of course this is the explanation and what it's called. I have one of these taped right in the front of my notebook I keep on my bench. All right, see you in the next video.